Bonjour, bonjour. On se retrouve aujourd'hui dans une nouvelle leçon. Et dans cette leçon, on va aborder la notion de connecteur logique. Okay, so how do we create compound propositions? All right, so we've looked at simple propositions like P with a multiple de 2. And par exemple, 2 est racine de 4. So we've looked at those simple propositions. But the question is, how do we create compound propositions? And what can we do with these propositions? Well, the first thing that we can do with a proposition is that we can negate any proposition. All right. So the first connector that we're going to be talking about is going to be la negation. Okay, so this is going to be our first connector, la negation. So for example, if P is a proposition, then non P, or so sometimes we can actually write this instead of writing no, but this is very, very common, non P. So is the negation, is the negation of P, is the negation of P. So basically, for you to be able to, to understand this concept, is I need to present to you what is known as a truth table. So a truth table is going to be now a summary of what is going to happen when we negate a proposition, taking into consideration all the possible cases, like all the possible states P can be. So P can be true, P can be false. And then what happens when we negate P when P is true? What happens when we negate P when P is false? So that is going to be summarized by what is known as a truth table, also known as the table de vérité. So table de vérité, vérité. So this is going to be our table de vérité. All right. So we have that. Now, if P is any proposition, all right, so let me just table de vérité pour la négation. So this is your P and this is your non P. So if P is true, non P is going to be false. If P is false, non P is going to be true. All right, so this is just what you're supposed to know about negation. So if P is true, non P is going to be false. If P is false, non P is going to be true. So that is all about negation. All right. So I can give you an example of a proposition, or rather an assertion, which we are going to negate, like the one we've been discussing. P, if P is the proposition that 8 est multiple de 2. Multiple de 2. So the negation non P is going to be what? Is going to be 8 n'est pas un multiple, multiple de 2. So actually here I'm supposed to say 8 est un multiple de 2. 8 n'est pas un multiple de 2. So this is going to be the negation of P. So actually 8 is a multiple of 2. So this is true. Now saying that 8 n'est pas un multiple de 2 is actually false, because we know that 8 is a multiple of 2. So it actually makes sense when it comes to this logical connector. So that is all for negation. So we move to the next connector. What is the next connector that we're going? What are we going to talk about next? So next we're going to have what is known as a conjunction. All right. What is a conjunction? So a conjunction is going to be when we have two propositions and we want to create a compound proposition. So we use the word and. So we say P and Q. So it's actually one proposition, and then maybe we can call it R, for example, and we can break it into two propositions, that is P and Q, that are connected by the word and. So that is going to be a conjunction. So it is going to be represented by, so P, and we have that symbol, and Q. All right. So we can read this as P, E, Q. All right. Or P and Q. So this actually means means P, and this actually means P and Q. So, all right. So now, what is the table de vérité? So we will consider all the possibilities that, or maybe all the possibilities. So what states can P be in, and what states can Q be in? All right, and we'll actually make that comparison. I mean that we'll make deductions from there. So we have that, and we have that. Maybe I can draw beta lines. All right, that looks good, and yeah, that looks good, and yeah, so that is beta. So if this is my P, and all right, so there's actually one thing missing. There's actually something missing. Actually, it's not a big deal. So this is going to be a Q. All right, this is going to be a Q. So if this is true, true, and this is false, false. So this is going to be true, false, and true, false. So we have all the possibilities. We can have that both these are true, both these are false, or either one of them is false or true. All right, so what is going to be P and Q? So the proposition P and Q is going to be true if and only if both P and Q are true. So it is going to be false in all the other cases. So this is going to be false, false, and false. If, for example, you have a proposition, let's say R, where we say 8 est un multiple de 2 et 2 est racine de 4. So is the proposition P and Q true? Yes, it is going to be true, because 8 is a multiple of 2, and 4 is the square root of, and 2 is the square root of 4. So that is going to be true. All right. So we have that. So that is a conjunction. So this is the truth table. So we've represented all the possibilities. All right. And now we move to what is known as a disjunction. All right. We now move to what is known as a disjunction. All right. Disjunction. So this is going to be our disjunction. So this is denoted by P, and we have that symbol, and Q. All right. So this is actually read as P ou Q. Now this is going to mean, this means P or Q. All right. So now we are going to write the table de vérité. So table de vérité. So we have that. Now I need to, I think, come up with proper lines. So we have that, and we have that, and that. All right. We have that, and that, and all right. Let me just write that. So we have 1, 2, 3, and I'm actually missing one more box. All right. So because we all know that this is going to be known as the table de vérité, I can get rid of this that is here, and maybe help myself with a line here. Oh my God. So we have that, and we have that. All right. So if this is your P, and this is your Q, and this is your P or Q, all right. So what we have these possibilities, all right, true, false, true, and false. So the proposition P or Q is going to be true if at least one of these propositions P or Q is true. So here both of them are true, so true. Here one of them is true, true. Here one of them is true, so true. And when both of them are false, unfortunately, the proposition is going to be false. All right. So this is what we call, this is what is known as a disjunction. So it's basically the or thing. All right. We now move to the third one, that is known as implication. So let me just get rid of this part. Let me just get rid of this part. All right. We go to implication. We now go to implication. So implication, otherwise denoted by P, and then we have this arrow, and then Q. So you have many ways of reading this. So you can say P implique Q, or you can say P entraîne Q, You can also say P alors Q, par exemple. Now, all this is going to mean P implies Q, P implies Q, or you can say P then Q. So these are actually different ways of saying the same thing. So basically, that is what we have for our implication. So now, what is the table de vérité? So now, this is going to be a bit tricky to understand, but I'll give you guys something that is going to help you remember the truth table. All right. So let me just write the truth table, and I think let me just come up with lines, and everyone is going to be happy. So we have that and that, and all right. So we basically have to have 4 boxes here. All right. So we have our 4 boxes, and we have that, and we have that. All right. So this is going to be our P, and then this is going to be our Q, and then this is going to be our P implies Q. So true, true, false, 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 or true, false, actually. All right. So this is going to be true, false, true, false. So the proposition P implies Q is going to be false only when the proposition P is true and Q is false. It is true in the other cases. So we have true here, here we have false, here we have true, and here we have true. Now, how are you going to remember this? Well, the proposition P and Q can be thought of as representing the idea of cause and effect. It can be thought of in those lines. So you can think about it as the idea of cause and effect. So whenever we have a cause, alors we must have an effect. Whenever there's a cause, there should always be an effect. Therefore, a situation where we have a cause and we have no effect is impossible. So this corresponds to the second part of our table here. So it is only P implies Q is only false in one situation. That is when true P is true and Q is false. The proposition Q implies P is known as implication réciproque de this proposition that we have here. So this is going to be the implication réciproque. The implication réciproque. So we'll talk more on this in the next connector. All right. When we start discussing the next connector, which is known as equivalence. So this is the reciproc of this that we have here. So remember that in implication, the only case where the proposition P implies Q evaluates to false is when P is true and Q is false. So you can think of it as the idea of effect, of cause and effect. So whenever there's a cause, we must always have an effect. So a situation where we have a cause and no effect is impossible. Hence, we have that that truth table there. All right, and we now move to the second connector. All right, so let me just take care of this part. All right, the next connector that we're going to talk about is going to be equivalence. Equivalence. So we have that. So equivalence. Okay, so what is equivalence? So remember that we're trying to come up with compound propositions. Okay, so equivalence is going to be represented by this. So we have an arrow with double arrowheads, with 2 arrowheads. So we have one on the left, one on the right. So P, we have P and Q represented like that. So this can be read as P, C est seulement C, C, si est seulement si est seulement si Q. Or this can be read as P équivaut. Actually, this is wrong. P équivaut Q. So what this means is that we're trying to say P is equal to Q, or we say P if and only if Q. So P if and only if and only if Q. This is what it means. All right. Now, what is the table de vérité? How does it look? So let me just draw some lines here and here. All right, there, there. All right. So this one is actually easy to remember. It's one of those easy operations to perform on any two propositions. It's one of those easy operations. It's not like the previous one. So P, Q, and then P, if and only if Q. So we have true, true, false, false. All right, true, false, true, false. So this is true in two cases only. So when both the propositions have the same Boolean value. So whenever P and Q are true, we have true. If one of them is false, well, they don't have the same Boolean value. So it's going to be false here, false, and then true here because they both are false. They have the same Boolean value. So that is equivalence. So now, from implication, if P implies Q is true and Q implies P is also true, then this is represented as P CSL mo C Q. So that's another way of saying that. So remember that if P implies Q is true, Q implies P is the implication réciproque. So if the implication réciproque is true, then and P implies Q is also true, then we are actually talking about P CSL mo C Q. So thank you guys for watching, and I'll see you in the next video.